Hello, General Chemistry. This is our fourth video in our balancing reaction series, and this one is going to be about combustion reactions. And when we went through the rules, we had a fourth bonus rule that I said that we would wait until later, and that time is now. And so when we get to that point in the balancing problem, then we'll share that fourth rule. So for combustion reactions, the first rules are the same. We need to list all of the atoms or unsplit polyatomic ions, and in this case, our atoms are going to be carbon, hydrogen, and oxygen. So we list those because they are on both sides of the equation, and then we count on each side. We've got a 2 here, and we have 6 hydrogen here, and we have 2 oxygen here, and when we come to the other side, we have 1 carbon on this side, 2 hydrogen on this side, and it looks like 3 oxygen on this side, a group of 2, and then this lone one over here. So we go through our rules as normal. There are no metals, there are no polyatomic ions, so we go to general nonmetals. We've got carbon here, so let's bring this number up. We'll put a 2 there, so we that changes to 2 carbon, and it also changes our oxygen. So we've got 2 groups of 2, so there's 4 oxygen here, and then there's 1 back here, so that brings us to 5. Now we go on. We've got carbon is balanced, so we can go on to hydrogen. We have 6 hydrogen on our reactant side, and we have 2 hydrogen on our product side, so we need more on our product side. We've got a group of 2 here, and if we need to get this to 6, we will need 3 groups of 2, so that'll turn that to 6, but that will also change our oxygen. So now we have these 2 groups of 2 over here for 4, and now we have 3 for that oxygen, so we bring that together, and that's 7. And now we get to the special combustion rule. The special combustion rule is if everything is balanced but oxygen, double the other coefficients, recount, and then balance oxygen. That is our bonus combustion rule. So right now, carbon is balanced, hydrogen is balanced, but oxygen is not balanced. So what do? Double everything. So right now, we've got an invisible 1 in front of this coefficient here, so we're going to turn that to a 2, double it. We've got a 2 already at this coefficient, so we're going to turn that to a 4, double it. We've got a 3 already in this coefficient, so we're going to turn that to a 6 to double it. Now we recount. Well, how much carbon do we have on this side? We have 2 groups of 2, that's 4. How much hydrogen on this side? 2 groups of 6, that's 12. And we're going to save oxygen for when we balance it. Now, on this side, we have 4 groups of 1, so 4 carbon. We have 6 groups of 2, so 12 hydrogen. And let's take a look. 4 groups of 2 would be 8 oxygen, plus 6 oxygen would give us 14 oxygen. So what do we need to put over here to get 14 oxygen? Well, we need 7 groups of 2, and that will indeed get us 14 oxygen. And we can take these blanks away, and that will be the balanced equation. In this combustion reaction, 2 molecules of dicarbon hexahydride plus 7 oxygen molecules react to yield 4 carbon dioxide molecules and 6 water molecules. We'll have to remember this bonus rule when we're doing combustion reactions, because if the oxygens aren't even, this will be what we need to do to balance it. I hope this helps. Struggle well.